Alright, so I'm going to go over in a little bit more detail the electronics involved in the Iron Man suit that I built for Slyfox. The majority of the electronics are housed here in the chest piece. Inside the chest piece we have mounted a massive 20,000 milliamp hour lithium-ion polymer battery, which can power the suit for 4 to 6 hours under normal use conditions. We also have the motherboard, I guess you could say, which consists of a Raspberry Pi, which is a type of mini Linux computer. Written on the Pi are the Python code executables and shell scripts, which control all of the functions of the suit. Over here we have an I2C compliant servo driver board, which takes commands from the Pi to produce pulse width modulation signals that dictate the control of the servos. This board also sends PWM signals to the custom printed PCB here, designed by Travis Kirk, which allows us to control the LEDs throughout the suit. Next to this we have a pull-up resistor network that allows the buttons hidden in the thighs to control the suit. Directly above it we have a temperature sensor. There's also an analog digital converter, which passes information from the battery to the Pi, allowing us to read the battery life remaining using the characteristics collected by Travis Kirk. At the bottom here is a USB hub, which allows us to connect the webcam, Wi-Fi adapter, and the wireless adapter for the control pad to the Raspberry Pi. There are also 2 speakers here and here to play back sound effects and music files. All along the outside of the chest piece are connection points for the LEDs, servos, and buttons throughout various places in the suit. Inside the chin here are the webcam and microphone. The webcam sees out through this small hole in the chin here. The webcam sends video to the Raspberry Pi via USB. The Raspberry Pi then uses the code written by Elijah Rockers to apply live time, temperature, and battery life statistics to the HUD mounted inside the helmet. The microphone sends audio from the user to the Pi, which then in turn uses the scripts written by Corbin Vader to execute voice commands. All functions inside the suit, such as the opening of the helmet or the playback of music files, can be controlled with either the control pad, the buttons in the thighs, or voice commands. If using voice commands, however, Jarvis will respond, like so. Jarvis.
That's your service, sir.
Jarvis, can the suit fly?
Sir, there are still terabytes of calculations needed.
Jarvis, open helmet.
As you wish.
Jarvis, close the helmet.
As you wish.
Inside the helmet itself is the HUD, which consists of some focusing lenses and a mini LCD, allowing the user to see out when the faceplate is closed. And behind the HUD are the LEDs, which light up the eyes. At the top of the helmet is the servo, which controls the faceplate. There is also a mechanism here, which keeps the faceplate in line and pushes open the jaw. And the jaw actually snaps onto the helmet, just like so. Alright, so now I'm going to show you what it looks like from inside the helmet. This is the Iron Man suit's boot up sequence. The program is set to launch as soon as the suit has finished booting up.
I have indeed been uploaded, sir. We're online and ready. Importing preferences and calibrating virtual environments.
Alright, so this is what the heads-up display looks like inside the helmet. The resolution is not great, and there is a noticeable screen door effect. However, it's still far superior to slits cut underneath the eyes in my experience. At the top, we have the time, temperature, and battery life remaining statistics. We can also change the color space of the HUD so that it gives an effect like heat vision or night vision, like so. Heat vision and night vision. All the functions of the suit can be used whether it's on a mannequin or on a person walking around a convention. That's pretty much it for the electronics. Thanks for watching. Be sure to check out our games channel. There'll be a link right here.
Test complete. Preparing to power down and begin diagnostics.
Whoa! Oh god!
Whoa!
Oh no! Jesus!
Okay.
Nope!
I think there's Oh my god!
I disappeared. I'm gone. I disappeared.
Oh, I look back, God.
No, let's just play this way. Come on, let's do it. Let's go to the wall.